Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 6, Section 3, Medians and Altitudes of Triangles. So a median is a segment in a triangle from a vertex, one of the vertices, to the midpoint of the opposite side. So let's draw one of them. There's from a vertex to the midpoint of the opposite side. If I do this again for another side, and then yet a third side, you see that they all meet at one place. And this one place that they all meet is a special place. It's called the centroid. It's the intersection of all the medians. The centroid has a special location inside of a triangle. What it does is it divides each one of these medians into a 2/3, 1/3 relationship. So it divides it 2/3, 1/3. And that's the same thing. This is 2/3, 1/3 relationship. The centroid theorem states that a centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if I follow 2/3 this way, 2/3 this way, and 2/3 this way, I get to the centroid of my triangle. Let's look at the problem that I have here. If from D to C is 21, then the length from C to X is going to be 2/3 of that, which is 14. If I know that XE is 4, then the distance from A to E is going to be 3 times that, or 12. Let's look at finding the centroid of these coordinates. So I have coordinate 2, 1, which is here. I have 5, 8. 1, 2, 3, 4, 8. And 8, 3. So there are my 3 points. If I want to find the centroid, what I can do is I can take make a median from one vertex down to the opposite side. So there's the midpoint of the opposite side. And I know that the relationship to the centroid is going to be a 2/3, 1/3 relationship. So if I go down 2/3, then it's going to be right there. So the centroid here is going to be right here at this point. And we'll continue this conversation in our next video.